So we are 1 minute past 2. We can start already. So today's webinar will cover monitoring of Kubernetes clusters using Prometheus, and it will focus also on the integrations we have at CERN. And it will be Diogo. Diogo is also part of the CERN Cloud team, of our team, and he will cover the setup and give some live demos. So go ahead, Diogo.
Hello, good afternoon to everybody. So yeah, I was presented already, so we can skip that part. Monitoring is important because it helps you see problems easier on a static load. For example, if you have a spike in a graph, you know that something is happening. So Magnum offers Prometheus as a monitoring infrastructure. And to do this is actually quite simple. You just need to use one label, monitoring enable equals true, and the cluster will come with a variety of monitoring tools. So when you use this label, there are various services that are installed. The main one is Prometheus, which is responsible to aggregate data, storage, and search this data. But it also comes with Grafana for end-user visualization of metrics, and alertmanager, which acts as a alerting platform that can process alerts by a defined hierarchy and dispatch them to different other services. Also, when you include this monitoring enabled label, another service is installed, which is the prometheus-adapter. Basically, prometheus-adapter is responsible to supply the Kubernetes API with instant metrics. We will use this later, so yeah. So this is an overview of the ecosystem and how the parts interact. As you can see, you have Prometheus that manages everything. Everything which is defined in Prometheus is based on manifests. And Prometheus, like Kubernetes services, uses a lot of match labels and target discovery. Also, in this loop, there is the prometheus-adapter, which contacts or queries the Prometheus server database and exposes the metrics on the Kubernetes metrics.gates.io endpoints and custom metrics endpoints and so on. So now I already have a cluster prepared, and what we're going to do is in the end, we are going to have a fully monitored cluster with an application, and we actually going to use that application, that monitoring, to scale our application in demand. So the first part is we are going to create a web app. This web app will basically expose endpoint, and the endpoint will, every time I query this URL, it will increment the total requests. So to do this, I deploy my app, and we can see what is here. So my app is very simple. I use a container. I have some resource requests, and I create a service. And now, if I port forward my service, I can actually service. I can actually query to see what's happening. So And now I curl. Oops. Okay, so you see every time I do a request, my counter increments. This is nice. So if I check my Prometheus server, uh, which I already configured, I can try and search for these metrics, which, by the way, I apologize because I chose a very similar name to this one, and it's not this one. So it's requests. So I have nothing called requests. I can actually see here. So it's called requests. So I have no metric called requests. This is a custom metric that I created. And now I want to actually scrape this metric and include it in my, and include it to be saved in the Prometheus data. So what I'll do is I create a service monitor. So I'll first create stuff and I can show after because it takes some time to do things. So one important aspect is that this is actually is a Kubernetes manifest that is based on CRD defined by the Prometheus. One important service monitor is something that aggregates services, basically maps, basically collect metrics from all the pods behind the service. And there are two important things here. So first of one is this match labels, which basically says, I want to select all services that match label app, sample app. And the second one is this release Prometheus operator label here, which basically is used by the Prometheus server to know that it needs to incorporate this service monitor in its configuration. And I'm collecting, the endpoint is this one, and the metrics by default, the URL it's dash metrics by default. So if I check now on my Kubernetes Prometheus cluster, I should see something. No. Okay. Um, okay, it still didn't load. Yeah. Sometimes this takes time to load. It depends how you get it. So yeah, I can show you like how. So I told you this is a custom resource definition, and every component in the Prometheus is defined by a manifest of a certain resource. So this, for example, is a manifest of the Prometheus type, which basically describes your Prometheus instance, which is this one that runs by default. And if we actually check what is here, we can see different definitions. And as I told you, one important thing is that the service monitor that it incorporates has to match this label. There's also another important one, which is for the rules. It has to match these two labels. So for example, if you can create another Prometheus server, for example, to match different labels, or like depending on what you want. Let's see if I have the metrics already. Okay, so here it is. So now my metrics are being scraped, okay? So this is a counter. So it counts accesses. And this is not very useful because what I actually want is a rate. So I can do give me a rate per second in a window of 1 minute of this metric. And so if I do this, I have something that is more like requests per second access to an API. Okay, this is cool. So I can do like request a lot of, make a lot of requests to generate some traffic. I don't know, just to prove that it's real. Okay, moving on. So, okay, I now have my application and I'm collecting metrics, but custom metrics that I expose in an endpoint. So as I told you, everything is defined by a file. So it's actually a good practice to have it with your code, because if you deploy your cluster in a GitOps way, it actually helps you to manage everything cluster related. Here is an example of all the CRDs that are defined by the monitoring. So we have alert managers, Prometheuses, and Prometheus rules, etc. So other thing that, okay, I have my metric, but now I can create what's called Prometheus rules, and Prometheus rules are of two categories. I have recording rules and I have alerting rules. Recording rules are basically useful when I want to make a complex query. For example, if I use this on my Grafana dashboard, and the query is complex and I have a lot of them, this will be processed at when this visualization is updated, which is bad because it will put a lot of load in the server. So what I can do is I can create a recording rule which basically does that, processes this metric or this calculation every scraping cycle. So it's based on another metric, but it's recorded as a new one. And what this does is it offloads the calculation processing through all time. So first, I'll talk about the recording rule. So what we're going to do is I'm going to give a basic example. I'm not going to do anything complex. So what I'm going to do here is I want to know how many pods are in my default namespace, for example. So, okay, so I selected the metric, which although will look so cut. Okay, so I can actually explore my Prometheus. I selected one, but for example, we can do pod, and then there's a lot of metrics that I can use, but I already selected one. So if I query this, okay, so I have all these metrics that is multidimensional, as you can see, and but this is a lot. I only want my namespace default pods. So what I can do is I can filter by namespace equals default. Okay, so now I have two. So basically one is from the pod, another is from the container, I guess. Okay. Oh no, this was from before. Yeah. Okay. So I have I want a sum. Okay. So sum of all the pods in the namespace default. So imagine that this is a complex query. So now I want to process this every time, like every 30 seconds, which is the default sampling rate of Prometheus. I can create a Prometheus rule that will do this for me. So I'll create a recording rule. And now we can see what's here. So my recording rule is part of it's part of the Prometheus rule kind. And again, notice this label necessary for the Prometheus server to incorporate this rule. I give it a name, and then this is other organizational stuff, which is not important for now. And this rule is executed every 1 minute. So here I defined an interval specific instead of the default, which is 30. I say calculate this every 1 minute. And the rule is what I had is like, give me the sum of all the pods on namespace default. And I'm recording this new result as demo. So my new metric will be called demo, will have the sum of the pods in the default namespace at the time that this was run. So to check that our rule was actually loaded, we can go to service discovery and check that it's actually discovering a container. Okay, I have one running. And also it's good to see targets here, which basically will say which containers are being scraped. So I have one target. Cool, so now let's see what, can I see demo here? Oh, okay, let's show here. Okay, I can see, well, it started now. So I have, right now, the sum of all my pods in the default namespace is 1. Nice. So if you have a complex query, distributing the processing that it takes, like per sample, it offloads the load instead of being at that moment. So this is important. Or if you want to do more complex queries, because Prometheus does not support nesting. So next, I want to do an alerting rule. So I want my cluster to alert me when my pods are over 4. So I can actually use the rule that I just defined. So I can do like pod greater than 4, which will not have anything because, well, it's 1. But if I do less than, okay, so it will show. Okay, so I can create a rule with this. Let's apply. Okay, I'm applying my rule, and now let's see what does this have. So again, check, important. It follows the same, almost the same pattern as the recording rule, but it has an alert. So my alert is called sample application at half capacity, and it will fire if demo it's greater than 4. So if I have more than 4 pods in the namespace default, it will fire. So I can actually check. Prometheus already comes with the default alerts, so I can come here and see all the alerts that are defined. Most of them are green. Watchdog is red because it's a watchdog. Some of them are red because I'm not implemented yet. And yeah, so my rule should appear here soon, hopefully. Okay. Okay, so, well, there's nothing to do but to wait. So while I wait for my rule to load, I can actually check if Prometheus already loaded it. So logs, and there's a container that manages this. I think it was already, okay. So Yeah, okay, so here it is, our rule, sample application at half capacity. It's green because we only have one. But now we can do is we can like test if this actually fires. So I'm gonna scale my application to 5. And so the pods are launching, so it still takes time. So now I should see my my alert is firing. So okay, and it says you have 5 pods, and it should trigger for greater than 4 pods. So now this is nice. I can actually go to the alert manager because Prometheus only valid applies the rules. And actually it's alert manager that is responsible for grouping and sending warnings to different kinds of platforms via email, Mattermost, whatever. So I can see which alerts are triggering. I can silence, for example, this node exporter, which is always complaining that has CPU throttling, but I define this to be correct. So I can say, I don't want to hear more from you, uh, and say, explain a reason or a comment and say, I'm silence you for 2 hours. Okay, so I create this and I don't have more alerts. Okay. Well, I do have that one should have been disappeared. Yeah. Okay. Yeah. Why is this not working? Alerts. Okay. Now it's correct. Okay. So, okay, I can manage my alerts from here.
Diogo, there's a question about can you silence an alert forever?
Uh, Not that I know. No. Well, you can put a really long time. Actually, this, for example, for this specific node exporter, um, like it's the we actually defined it to be close to limit, so it always work even if the compute node is under load, heavy load, but because it has um, specific resources, it should always work. But apparently this always gives a warning, and this is something that I need to do, like to silence this or find a way to silence this. But as far as I know, no. So, okay, I created an alert. Okay, moving on. So I'm going to scale down my, I'm going to scale down back to where I was. And now, if this gets out of here, okay. And now, so this is really cool. I did an application. I exposed the custom metric. My metric is being my metric is being saved. I can actuate and send alarms based on my metric, but I can do more. So one thing I can do is, and it's because of the Prometheus adapter, is that I can use the Prometheus metrics to scale my application. So the way this works is Kubernetes has 3 metrics APIs. So the one you use when you do kubectl top nodes is the metrics.k8io API. So these metrics here are supplied by the metric server, but Prometheus adapter can actually do the same, but based on Prometheus metrics, and it can actually supply metrics on all the the APIs. So, but now, how is it defined now? It exposes the Prometheus metrics in the custom metrics Kate's IO. You can check which APIs are available by doing kubectl API versions and grabbing the metrics, and this will be your result. So why do we use prometheus-adapter and cannot use Prometheus server directly? Because this is like instant metrics. Basically, what the adapter does, it's actually as processing for itself, but it follows rules, but it follows it queries the Prometheus from time to time, which is default is it queries from 1 minute to 1 minute, and it comes with already defined default grouping of metrics from the Prometheus server, which basically says from 1 to 1 minute, give me averages or maximums or whatever in a window of 3 minutes of all the different metrics. This is a very rough explanation. So basically, it just exploits like it's a value now. It's basically what it does. Every time you do a get, you get a value now. So I can actually see what kind of metrics are exposed by Prometheus adapter. So if I do this, I have all these metrics. Well, this is a lot, okay? But what I'm interested is actually, I want to get the metric that I defined. So I can actually, like if I do a query, I can query, give me from the custom metrics API, all the pods that have this metric, and actually it selects by application label. So, and then it responds like, I have one pod and the pod has a HTTP requests of 33 milli. So basically is one request, 0.033 requests every 1 second. Okay. Okay, this is nice. So because now what I can do is that Kubernetes offers a horizontal pod autoscaler. What this does is that I can horizontally scale my application to meet load demand. In this case, I'm using a custom metric, which is requests per second, let's say, and I want to respond to this. So I'm going to use the custom endpoint, and I'm gonna. So what I'm going to do is I want to have one pod per half request a second. Sorry. Okay, it's easier if I show. Okay, so what I'm going to do is I want my target application, which is the sample app, scale between 1 and 10 pods. And the metric that I'm going to use is of type pods, which basically will do the average of the existing pods. And the metric name, which is HTTP requests, as we saw when we queried the Prometheus when you queried the custom metrics endpoint. And I want to scale to meet one request every 2 seconds per pod. So, okay, if I check my sample application, I have these requests. Okay, because I have no load, that's correct. I only have actually the Prometheus that scrapes the pod. So what I'm going to do is, okay, there's nothing here. what I'm going to do is I'm going to create some load. So if I do one request every 2 seconds, it will actually stay the same because it already meets the demand. And this is just interesting to see like the graph after. So if I make 2 curl requests per second, I should have 4 pods, right? So what I'm going to do is I'm going to do this. I'm going to say, make me 2 requests per second. And what we should see is actually I'm doing this in the wrong place because I need, okay, let me change these. I need this. Okay, I'm going to do this. Okay, it's running. So I can now check what's happening. So load is increasing, okay, which makes sense. But it's still, as I told you, it takes time. So because it has the delay of the Prometheus server, it has the delay of the prometheus-adapter, which has a 3-minute time window. So this will go to 4 pods minus some pods because there is like you cannot get a precise value. You always have a deviation. So that's actually 5%, or if it's around 1, like you divide the targets, what you want and what you have, and if it's around 1, it doesn't scale, or yeah, that's how it works. So let's see. Okay, so it's going up. Okay, so now that we are going up, we should start see next time it updates, it actually should start and see some pods being created. Okay. Okay, not yet. So this is like, this should be tuned to your specific case. Like if you have a very sensitive application, you should have a margin. If not, and you can tolerate some minutes with your application being saturated, it's also, it's up to you. So okay, so now it should start. We should start and see it triggering something. Okay, so now I have two pods, and yeah, so now this will actually keep increasing, but yeah, it will take time. Well, what if I have a spike of requests? Until now, I'm like, my load is not that much, but if I do something crazy, like I request a lot of stuff, I can actually create a spike. So yeah, so while this is running, this will actually in the horizontal pod autoscaler will trigger the metrics collected will have a very big spike, and the amount of pods it actually deploys, it depends on the metric. So if I have a bigger spike, I will have more pods launched to meet that demand. So yeah, so I have 4 requests per second now as average, and I have 2 pods, so it should scale like to more than 10. Yeah. So while this is going, okay, I see pods being created. Okay, this is nice because it's actually doing what I wanted. I want it to scale based on my requests. You can imagine this as being a queue, for example. Okay, cool. Well, I think this is it. We can check actually interesting stuff. Interesting stuff is that uh, I actually made on purpose. There's no space to put this pod. So there, my maximum is 10 pods, but I actually only have space to 9. So what is going to happen is that I'm going to have this pending pod here indefinitely. This is nice because if you have activated cluster autoscaling, it will actually launch a new node that was triggered by this horizontal pod autoscaling. So you can use resources on your cloud by user demand. This is really good. So I think that's it. We can see, I can show you like the alert is firing again. And actually there's more default alerts that come with the Prometheus. Um, mm, some of them related to horizontal pod autoscaling, some of them related to pod not ready. So these ones are yellow because they only fire after 15 minutes. So here I see kube deployment replicas mismatch. This means that I don't have the same pods that I want in my replica set. Pod not ready. HPA, horizontal pod autoscaling is maxed out. So this is Kubernetes. Prometheus already comes with a lot of Kubernetes defined objects, and it actually warns you if something is missing or is not working well. Yeah, so I think that's it. Yeah, I actually didn't show you the Grafana dashboard, so it's something like this. You have cool graphics, and I can actually draw my defined metric here. You can actually use this with the central monitoring Grafana by setting the export the data source from your Prometheus. You can access it centrally. So if I do here and I search demo, which is my metric, I should see something happening, hopefully. Now, okay, cool. So yeah, we started at 1, then we scaled to 5, then it went at 1 again, and my computer broke. Oh, okay. Okay, so that's it. I hope
Okay, I think we lost Diogo again. Hey there.
still here.
Okay, you can still hear me, Spears?
Yep, I can hear you.
Okay. I think Diogo's computer froze again. But I think he was about to finish. I don't know if anyone has some immediate questions. Feel free to either raise your hand or write them in the Q&A, and maybe in the meantime Diogo comes back. Okay. Okay, so there's a question from, maybe Diogo is back. No, he's gone. Maybe he will connect. There's a question from Diego. Can we expose Prometheus as we do with Grafana through ingress and password protected? So the answer is for ingress is yes, but to be better that Diogo replies. So let's just wait a second.
As far as I know, for password protected, Prometheus does not support this natively.
Yeah, that's why we didn't add the ingress, but yeah. But I can give you, wait, I'll do better. Diego, do you want to ask yourself maybe the question? I gave you the microphone.
Yeah, can you hear?
Yes.
Yeah, I was just wondering, just for easily documenting this and sharing with the team, because it seems that we have to go and do port forward, and it's kind of convoluted. If someone is new and has to do it quick, it would be easier as we do with Grafana, because right now we just have a piece of documentation that points to an URL, and we have a secret, and the person would go with this password and modify things there. I was just wondering if this would be possible.
For
Otherwise,
Grafana,
we can.
Yeah, you have this for Grafana and you would like for Prometheus.
Yeah.
Yeah, makes sense. But a lot of this visualization that he was showing, you can also see it in Grafana directly. Not for the, well, also for the alerts, but it's a different system. But for the metrics visualization, they are all available in both.
So can you still hear me?
Yes.
Yeah. So it's just about the configuring the alerts, right? That we would need to access there.
Yeah. There is another system in Grafana as well, but you have to use the Prometheus alerts. You would need to do this. Yeah. I think Diego can give you a couple more details, but he was unlucky with his setup today. I'll just give him a couple more seconds to try to reconnect. In the meantime, if anyone has any other question, I actually had a request for Diogo to stop the load and see how the HBA would also scale down, although it can take a bit eventually.
Sorry.
Oh, he's back.
Well, this didn't happen before, so this one.
So Diego,
okay, so sorry, questions.
There was a question from Diego about exposing Prometheus the same way we can with Grafana with ingress and the password to configure the alerts.
Okay, so there's already two things that are not included in the Prometheus in the monitoring now, which basically are possibility to define different scraping intervals. So default is 30. You can go. I think it's safe to go until 5, but it actually has impact on data storage, so use it at your own risk. You can also define external storage for your Prometheus server data. So, for example, because if the pod dies, all the data dies, but we actually did some integration with the central monitoring to cover this. In the case for exposing the Prometheus from outside, this is also done. It's waiting for merge upstream. What I did was I allow you to specify a cluster FKDN, and I then expose all the three services actually through so your cluster dash Grafana, your cluster slash Prometheus, and your cluster slash alertmanager. This is nice because, and it actually implements password. It actually requests password on alertmanager and Prometheus by using the nginx ingress or the traffic one. This is nice because if you send the alerts to Mattermost and your instance is accessible through URLs, you can click the URL that is available in Mattermost, and it will take you to the graph that is to the alert that is actually triggering that alert, and then you can navigate through the chart and see what's happening to that specific alert and why it's fired. So this will come, but it's still pending. So yeah. Am I down? No.
Okay, thank
Hello?
you. And so I guess, yeah, the other thing that we were mentioning just before you rejoined was, so you also about, because in the Grafana you can also have alerts, and the metrics can be seen in both. So but basically this is the same information in both Prometheus and Grafana.
So the alerts from Grafana, is that it?
No, like the metrics, the data
Uh,
is like what you see in Grafana and Prometheus. I guess the source is the same, which is Prometheus. And for the alerts?
Yeah. So yeah. So for the data, the metrics and the graphics you visualize, you basically use Prometheus to find what you want, and then you make it fancy and user like on the Grafana side. So because Prometheus you can actually only do like one graph per request. For the alerts, it's not the alerts from Grafana are not the same. So I actually don't know if Grafana can be used as a alert manager itself, but if it can receive um, the push from the Prometheus server and recognize the alert from the Prometheus server, you can use it as to display alerts. Is this your question?
I think that was the question. Yeah. So, but basically, it's still useful to access Prometheus directly to configure the alerts and manage the alerts. That I think that was the question.
Yeah, so you manage the alerts is silencing, grouping. So the part of grouping alerts is actually defined with a secret on the Kubernetes. We want to make this some sort of variable, because now we have to edit this manually. You cannot pass like a secret name to be your alert manager configuration. I read upstream that they were thinking on doing custom resource for this. I don't know how that is. This was actually quite recent. So yeah.
Okay.
If I want, I can show you. Well, maybe not, because, well, if you feel adventurous and like you can edit your secret, and if you put this, which is basically the definition for the configuration of the alert manager, you can see that, for example, so this is my definition. So I have a receiver for my alert, which basically is a webhook. You can use a webhook, and like the name is Mattermost, and I use this endpoint, and then I group my alerts by alert name, cluster, service, and pod name, and this is it runs every 5 minutes, and it waits 1 minute before sending an alert. So this is actually quite complex. You can have, for example, you can have an alert tree. For example, you can scale to the third line of support, or only to the first one, depending on the severity of the alert. And this is defined by the labels that the alert comes with. So the labels are posted by Prometheus, and then depending on what you find, you sort it differently.
I don't see any other questions, so I think that's it for today. Thanks a lot, Diogo. And so next week we'll have one more, and see you there.
Thank you.